I welcome you all for a brief video presentation on the topic memory belonging to the subject digital design and computer organization. My name is Bharath. I belong to third semester of computer science, engineering and artificial intelligence department. The subject which I'll be discussing through this video is the digital design and computer organization, and the course code is BCS 302. So let us look into the video now. A simple video which will look into types of memory in computer first, then let us have an introduction. Memory in computers plays a crucial role in storing and retrieving data and instructions. Memory is categorized into different types based on various criteria such as speed, cost, and capacity. Understanding these memory types is essential for designing efficient computer systems. Memory in computers play a crucial role in storing and retrieving data and instructions. Memory is categorized into different types based on various criteria such as speed, cost, and capacity. Understanding these memory types is essential for designing efficient computer systems. This was about memory types in computer. Now let us look at primary memory. What is a primary memory? What is the definition of primary memory? Primary memory is the main memory of a computer directly accessible by the CPU. It is volatile, meaning it loses its contents when the power is turned off. Primary memory is crucial for storing data and instructions during program execution. This is the definition of primary memory. Next, the primary memory is the main memory of a computer directly accessible by the CPU. The primary memory is volatile, meaning it loses its contents when the power is turned off. Primary memory is crucial for storing data and instructions during the program execution. This is about primary memory. Let us look at the next slide. Random access memory, which is RAM, random access memory. The characteristics of random access memory are speed, faster access to data compared to secondary memory, cost, which is more expensive per unit of storage compared to secondary memory, volatility, data is lost when the power is turned off, RAM is essential for multitasking and storing data temporarily during program execution. RAM is essential for multitasking and storing data temporarily during program execution. This is about random access memory. Speed is faster access to data compared to secondary memory, which is more expensive per unit of storage compared to secondary memory. These are some of the characteristics of random access memory. This is about the slide. Let us go to the next slide. So, here in this slide on read-only memory, let us look at some of the characteristics of ROM. Speed is a subtopic. First, faster access to data compared to secondary memory in read-only memory. Cost is more expensive per unit of storage compared to secondary memory. Volatility, data is retained even when the power is turned off. ROM contains firmware or built-in programs essential for booting up the computer. This is about read-only memory. And these are the characteristics of the read-only memory. Faster access to data compared to secondary memory, more expensive per unit storage and compared to secondary memory. Then volatility is the data is retained even when the power is turned off. ROM contains firmware or built-in programs essential for booting up the computer. Secondary memory, the definition is secondary memory is used to store data and programs on a long-term basis. It is non-volatile, meaning it retains its content even when the power is turned off. Secondary memory provides a larger storage capacity compared to primary memory. This is about the secondary memory. Secondary memory is defined as a storage used to store data and programs on long-term basis. It is non-volatile, meaning it retains its content even when the power is turned off. Secondary memory provides a larger storage capacity compared to primary memory. This is about the secondary memory. In the next slide, let us look on the different types of secondary memory. The first is LPDDR, which is low power double data rate. This is used in mobile devices for its low power consumption and high bandwidth. UFS, which is universal flash storage, provides higher data transfer speed and lower power consumption compared to eMMC. eMMC, which is embedded multimedia card, commonly used in budget and mid-range smartphones for its cost effectiveness. These storage types impact the performance and user experience of smartphones. This is about the secondary memory. Three types here: LPDDR, which is low power double data rate; UFS, which is a universal flash storage; eMMC, which is embedded multimedia card. These are the three types of secondary memory. Low power double data rate, which we saw just now, one type of secondary memory, which is acronym is LPDDR. The features of LPDDR, first thing is about power efficiency. LPDDR, which is low power double data rate, offers improved power efficiency, extending battery life in mobile devices. High bandwidth is seen in LPDDR. This provides high data transfer rates, enabling smooth multitasking and faster app loading. LPDDR technology is constantly evolving to meet the increasing demands of mobile devices. These are the main features of low power double data rate thing. The next one will be on universal flash storage, which is also called as UFS. The features of universal flash storage is, first thing, let us see on high speed. UFS offers faster data transfer speed compared to eMMC, which is embedded multimedia card, improving overall system performance. Low power consumption, which is consumes less power, contributing to longer battery life in mobile devices. UFS is becoming the standard for high performance storage in smartphones and other mobile devices. This is about universal flash storage. With high speed, low power consumption, these two have now become the standard for high performance storage in smartphones and other mobile devices. This is about the UFS. Embedded multimedia card, which we just saw now, eMMC. Features of embedded multimedia card are: they are cost effective, that is eMMCs is more cost effective compared to UFS, making it suitable for budget and mid-range smartphones. This is a very decent performance, that is it offers decent performance for everyday tasks but lags behind UFS in speed and efficiency. eMMC remains a popular choice for budget conscious consumers and entry-level smartphones. This is eMMC. Cost effective, decent performance, remains a popular choice for budget conscious consumer and entry-level smartphones. These were some of the main features of an embedded multimedia card. And the next one is the comparison. Speed. Primary memory, which is RAM, random access memory, is faster than secondary memory. The next one is cost. Primary memory, that is RAM, is more expensive than secondary memory. Volatility, that is the primary memory is volatile while secondary memory is non-volatile. Understanding the trade-offs between different memory types is crucial for designing efficient computer systems. This is some of the comparison between the primary memory, secondary memory and the tertiary memory. whatever the memory systems are possible under three parameters, which is speed, cost, and volatility. Let us now look at the next slide, which is Memory Management Unit, the MMU. Memory Management Unit. Let's look at its definition. This is a hardware unit that manages the mapping between virtual addresses used by programs and physical addresses in RAM. It helps in providing virtual memory, which allows programs to use more memory than physically available. MMU plays a crucial role in memory protection and address translation in modern computer systems. This is about the memory management unit, its definition, and the three other points of MMU. Addresses and programs, physical addresses in RAM, providing virtual memory physically unavailable, which allows programs to use more memory. This was the memory management unit. Virtual memory, the definition: virtual memory is a memory management technique that provides an illusion of a larger memory space than the physical RAM available. It allows the operating system to use disk space as an extension of RAM. Virtual memory helps in improving system performance by efficiently managing memory resources. This is about virtual memory, and the definition of virtual memory is as such. Next, we'll see virtual memory as a good memory management technique that provides an illusion of a larger memory space than the physical RAM available. Allows the operating system to use disk space as an extension of RAM. Virtual memory helps in improving system performance by efficiently managing memory resources. Next, let us look at the page table. What is the definition of a page table? A page table is a data structure used by the MMU to map virtual addresses to physical addresses. It stores the mapping information for each page of memory. Page tables are essential for efficient address translation and memory management in modern computer systems. This is a definition explanation of the page table structure used by MMU to map virtual addresses to physical addresses. Stores the mapping information for each page of memory. Page tables are essential for efficient addresses, translation, and memory management in modern computer systems. This was the page table. Next, let us look at paging. Paging is a memory management scheme that eliminates the need for contiguous allocation of physical memory. It divides the physical memory into fixed size blocks called pages and the virtual memory into blocks of the same size called page frames. Paging allows for efficient use of memory resources and simplifies memory management in modern operating systems. Paging is a memory management scheme that eliminates the need for contiguous allocation of physical memory. It divides the physical memory into fixed size blocks called pages and the virtual memory into blocks of the same size called page frames. Paging allows for efficient use of memory resources and simplifies memory management in modern operating systems. Paging is a memory management scheme that eliminates the need for contiguous allocation of physical memory. It divides the physical memory into fixed size blocks called pages and virtual memory into blocks of same size called page frames. Memory hierarchy. Memory hierarchy refers to the arrangement of different types of memory. Um, this is about the cache memory. I'm sorry for the interruption. Cache memory is a small, high-speed memory located between the CPU and the main memory. It stores frequently accessed data and instructions to reduce the average time to access memory. Cache memory plays a crucial role in improving the performance of modern computer systems by reducing memory latency. This is about the cache memory. Next, let us see what are the types of cache memory. First, it's L1 cache, closest to the CPU but it is small in size, that has the fastest access time. L2 cache memory is located between L1 cache and main memory. It is larger in size but slower than L1 cache. L3 cache is shared among multiple cores in a multi-core processor. It is larger but slower than L2 cache. Cache memory hierarchy is designed to minimize the latency of memory access in modern computer systems. Located closest to CPU, small in size, fastest access time. Cache mapping techniques, direct mapping. Each block of main memory maps to allow only one cache line. Associative mapping. Each block of main memory can map to any cache line. Set associative mapping. A compromise between direct and associative mapping, where each block of main memory can map to a set of cache lines. Cache mapping techniques are designed to optimize cache performance and minimize cache conflicts in modern computer systems. The techniques are direct mapping. Each block of main memory maps to only one cache line. Each block of main memory can map to any cache line in associative memory, and this is about cache mapping techniques. Memory types in GPIS. There are four types of memory in GPIS: VRAM, GDDR, HBM. And in conclusion, we have whatever we have studied, there is memory in computers, memory types and characteristics, primary and secondary memory, LDPPR, LPDDR, UFS and HBM, and overall memory management is a critical aspect of computer architecture, impacting system performance, power consumption and cost. Thank you very much for being a part of the video. See you soon in the next video. Thank you.